than the outer layer of space-time. It can stay aware of it, and it'll fundamentally tear. I'm frightened by this. As of now, our night sky is changing quickly, and in a matter of various years, if not sooner, it could turn out to be totally unrecognizable. Cosmologists, for the most part, are sounding the alarm. Specialists like Neil deGrasse Tyson have confirmed the inevitable impact of Polaris, and the story behind it is quite astounding. Polaris, known as the North Star, has for a long time been a constant in our night sky, serving as an essential reference point for stargazers, navigators, and space experts. Regardless, this could soon change, altering our night sky and cosmic evaluations. Let's dive into the significance of this threat and its implications for all of us. Join us as we uncover the narrative of Polaris as it nears its end. For a long time, Polaris has guided sailors and stargazers alike, standing firm as a guiding light. Its steady presence in the night sky has been essential for navigation. However, this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society shed light on the fate of this remarkable star. Polaris is near the unstable edge of exploding, potentially disappearing from the night sky forever. Before we explore the consequences of this revelation, let's learn about Polaris, also called the North Star or Pole Star. Polaris is unique due to its proximity to the celestial North Pole, positioned directly above Earth's North Pole. It appears almost stationary in the northern sky and is located in the constellation Ursa Minor, or the Little Dipper. Polaris shines as a moderately bright yellow-white supergiant star, significantly larger and brighter than our Sun. It is not a single star, rather it is part of a complex triple star system, with Polaris A and Polaris B forming a binary pair. While Polaris B orbits them, the interactions between these stars generate gravitational forces that shape their orbits and influence their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the specific mechanisms behind these interactions remain complex. Polaris is located about 323 light-years from Earth, meaning the light we see from it today began its journey centuries ago. If Polaris were to explode now, we wouldn't see the event for over 300 years. It's even possible that Polaris has already exploded, and we are yet to witness the light from that event. Historically, the North Star has held immense cultural, navigational, and symbolic significance. Its steadfastness and fixed position made it an invaluable guide for ancient mariners, helping them navigate across seas and lands. Symbolically, Polaris represented stability and direction, remaining unwavering amidst the ever-changing night sky. Forest astronomers, Polaris served as a critical reference point, aiding the study of celestial movements and variable stars. As a said variable star, its periodic variations in brightness have provided crucial insights into stellar properties and the nature of variable stars. This characteristic also played a vital role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, making Polaris a standard for tracking stellar behavior. However, recently Polaris has deviated from this standard behavior. This anomaly in its pulsation cycle has puzzled astronomers, prompting a closer examination of this curious irregularity. Instead of following its usual pattern, Polaris has started exhibiting erratic dimming patterns, raising concerns among scientists that the star may be nearing the end of its life. This aligns with behaviors commonly observed in stars approaching the final stages of their life cycles. The gradual expansion of Polaris's pulsation period, one steady, can be attributed to interactions within Its star system scientists have observed an annual increase in pulsation length of 4.5 seconds, which, though minor, hold significant implications. Some astronomers suggest that gravitational interactions among the Polaris stars could be causing these changes in its atmospheric conditions directly, impacting its pulsation patterns. Others are more concerned that Polaris is near the critical threshold of exploding. The similarities between Polaris's behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex irregularities in their brightness, raising concerns about a possible explosion, as stars in their twilight stage often exhibit such anomalies before reaching the end of their life cycles. NASA has expressed heightened concern about Betelgeuse. However, formal attention has not yet been directed toward Polaris as a SAID star nears the end of its life cycle. It undergoes several stages, including the primary phase or red giant phase, and finally the supernova explosion. Given Polaris's irregular pulsations, scientists predict it has entered the stages of helium depletion typical of giant stars nearing their end. These irregularities in Polaris's behavior align with patterns common in stars in their twilight phases. If Polaris were to undergo a supernova explosion, it would likely be a massive event in our sky, potentially outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance could significantly alter our view of prominent constellations, like the Big Dipper or Ursa Major, of which Polaris is a part. Rest assured, Earth would likely remain entirely safe, given Polaris's mass and distance from us. While a Polaris explosion may not be as visually spectacular as Betelgeuse, it could still be visible to the naked eye for an extended period, outshining nearby stars. Astronomers and observatories would undoubtedly take notice, sparking interest within the academic community and among stargazers. However, the impact on Earth's environment or atmospheric systems would be less significant compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? It's important to clarify that while massive stars typically end their lives with a supernova explosion, this is unlikely to be the case with Polaris. When a massive star undergoes a supernova, a tremendous explosion occurs within it, marking the final catastrophic stage in its life. This process involves the complete collapse of the core, triggering a violent shock wave that causes the star to explode. However, Polaris isn't massive enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This transformation won't result in a supernova, but rather a quiet ending as it evolves into a small, incredibly dense stellar remnant. A white dwarf is the leftover core of a low or medium mass star that has exhausted its nuclear fuel. It is incredibly dense, about the size of Earth, but as massive as the Sun. When this happens, we will no longer see its remnants from our planet, contrasting the bright, steady star we observe today. Comparing the potential effects of a Polaris explosion with actual supernova events offers valuable insights into the evolution of stars and their ultimate destinies. For instance, past supernova like SN 1987A in the Large Magellanic Cloud and SN 1054, which led to the creation of the Crab Nebula, have significantly expanded our understanding of stellar processes. These events provided insights into the mechanisms of nucleosynthesis, the formation of supernova remnants, and the role of such explosions in enriching the interstellar medium with heavy elements. The Crab Nebula, for example, continues to emit radiation across various wavelengths, offering a rich field of study for astronomers. In the Case of Polaris, the absence of a supernova might lead to less dramatic changes in the surrounding interstellar medium. Still, its transition to a white dwarf would be a testament to the natural life cycle of stars, emphasizing the quiet yet profound evolution that medium-mass stars undergo for humanity. Polaris's eventual transformation will mark the end of an era. The loss of this steadfast celestial guide will leave a gap in our night sky, altering our cultural, navigational, and astronomical heritage. As we look to the stars, the story of Polaris reminds us of the ever-changing nature of the cosmos and the impermanence of even the most reliable celestial objects in the years to come. As scientists continue to monitor Polaris, we may gain deeper insights into its behavior and destiny. For now, Polaris remains a beacon of curiosity and wonder, inviting us to explore and question the mysteries of the universe. Has suggestions for astrophysical cycles and vast radiation conditions to make a conclusive correlation. Researchers are assessing contrasts in the enormous scope, creation, and speed of launch materials between polarizers, expected blast, and other noticed occasions. This includes concentrating on the light curve spectra and remnants of these events and extrapolating comparable qualities for Polaris's expected blast, assessing whether it might prompt the development of nebulae or huge heavenly disseminations. This improves our understanding of its potential results. Another significant area of study involves examining the pulse variability of stars moving toward their end stages, comparing Polaris against other supernova ancestors. This general examination can help estimate similarities or deviations and provide insights into the explosive mechanism. Pulsational variety in stars nearing the end of their lives might be indicative of internal hazards or looming catastrophic events, offering signs of the formative processes leading to supernova blasts. Despite careful observations and extensive research, space experts remain confused by the peculiarities found in Polaris's behavior, unraveling the unique circumstances driving these anomalies holds the key to advancing our understanding of stellar evolution. Understanding the dynamics responsible for Polaris's irregular throbs requires interdisciplinary collaboration, as well as the development of advanced theoretical models and observational methods. The possible loss of Polaris as a critical reference point in the night sky raises key questions for astronomical undertakings. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of cosmic assessments. The absence of Polaris could also impact navigation systems and cultural practices based on celestial landmarks, highlighting the significance of this stellar event. The mysterious behavior displayed by Polaris underscores the need for deeper investigations and dedicated research efforts. Astronomers must wrestle with the complexities surrounding its irregular throbs and provide meaningful responses, recognizing the importance of advancing our understanding of stellar complexities. The answer to Polaris's fate remains uncertain, and only time will reveal its true nature. Still, the quest for knowledge and understanding, despite massive uncertainty, is a testament to humanity's enduring curiosity about the mysteries of the universe. The implications of Polaris's potential end stretch beyond simple astronomical interest. They address the very fabric of how humanity perceives its place in the universe. Since the earliest days of reported history, celestial bodies have served as markers of time and navigation, guiding travelers across uncharted waters and lands. The loss of Polaris wouldn't just disrupt traditional navigation methods, but could also have sweeping implications for cultural legends and symbolism tied to the North star in various cultures. Polaris has been vital to folklore and spirituality. For example, Native American tribes often viewed Polaris as a guiding light in their stories, symbolizing hope and constancy. Similarly, the ancient Egyptians used the North Star in their architectural designs, aligning pyramids to its position. The disappearance of such a prominent star could alter cultural narratives and the framework of human experience related to navigation and direction. Furthermore, the academic community stands to face significant challenges if Polaris were to vanish. Astronomical measurements and observations heavily rely on established reference points. Polaris's role as a constant guide has facilitated the calibration of instrument and models used to study distant world star formations and even the expansion of the universe. The sudden absence of Polaris would require recalibrating many of these systems, potentially leading to discrepancies in measurements and interpretations of stellar phenomena as astronomers shift their focus to observing Polaris more closely. New observational advancements are being developed. Progress in spectroscopy and photometry enables scientists to examine light emitted by stars in unprecedented detail. These tools help identify minute changes in brightness, which are essential for understanding the mechanisms driving stellar behavior. As researchers gather more data, they aim to refine their models of stellar evolution, particularly concerning stars in the later stages of their life cycles. The study of other similar stars, such as seeds and red giants, offers insights that could prove invaluable. For instance, astronomers are observing factors like the period luminosity relationship, which helps in measuring distances across the universe. By comparing these stars' behaviors with those of Polaris, researchers hope to gain a clearer understanding of stellar dynamics and evolution, further enhancing their interest in the design of our universe. In addition, as the search for exoplanets intensifies, the study of Polaris and its companions becomes increasingly significant. Understanding the characteristics of stars and triple systems can provide valuable insights into the formation and habitability of planets orbiting them. Astronomers are keenly interested in how such stars affect their surroundings, potentially influencing the conditions under which planets form and evolve.